So we're on page 23 of our notes. We have been talking about these inequalities, and today we gotta look at one that's a little bit a type. It's a little bit different. So this is problem number 10. Here we are, problem number 10. And we need to solve this thing. What you can't do is multiply over the x minus 3. I know you want to do that, and if it were an equation, you could absolutely do that. But since it's an inequality, you cannot multiply this over. So in other words, kids, do not say this. This is wrong. Now, why is it wrong? Because it makes sense. It seems like I should be able to do that. When you multiply in an inequality, do you remember there's a special rule for that? What's the special rule? You know? Sometimes we flip, right? Do we always flip? No. We flip the sign if what we multiply by is negative. When a variable is involved, do I know whether that's positive or negative? I don't have a clue. Because if x is 5, it's positive, but if x is 0, it's negative. And when I multiply, I have to know what to do with that sign. So since I don't know if that's positive or negative, I can't multiply. So what do we do instead? Don't do that. Please, don't do that. It's what you want to do, it's tempting, I get it, but it's wrong. And I can't give you partial credit for it, because it's just wrong. So don't do that. Instead, what you do is this. Don't we like to have zeros in our inequalities? Now, I just erased all those problems, but every single one of those, we had a 0 on one side. So I'm going to go ahead and subtract the 4 over to the other side. Now that 4 is like 4 over 1. So now I'm going to get a common denominator. And the common denominator, it's like what you just did on your quiz. The common denominator would be x minus 3. So I'm going to multiply this one by x minus 3. Now the difference is, in an inequality now, I'm not allowed to lose the denominator, so I have to keep the common denominator. And then look at the numerator. So the numerator will be x plus 2. Watch this carefully. Minus 4x plus 12. So I subtracted the 4 over to get the 0. Multiplied the top and bottom here by x minus 3 so that the denominators matched. Then I wrote one fraction with that denominator and then all the numerator up there. Okay, what do you think I'm going to do now? I'm going to clean up that numerator. So that's going to be negative 3x plus 14 over x minus 3. Now it looks just like the ones we did the other day. We're going to have 2 dots on our number line. One of the dots is going to be at 3. Would you agree? When there are all those numbers and negatives and stuff, it's confusing to me to figure out where to put the dot. So I can always, over to the side, just set it equal to 0 and solve it, and that tells me where to put the dot. So I took my numerator, I couldn't tell where the dot was. So I set it equal to 0, solved it, so that dot's at 14/3, which is 4 2/3. So I have it open, or I'm going to put a dot at 3 and a dot at 14/3 or 4 2/3, however you want to write it. Now less than or equal to, does anybody remember what we talked about last time? What did we say about denominator dots? They're always open. So if the dot came from the denominator, it's gonna be open, but I can close in the other one because of the or equal to in the problem. So denominator dots are always open. Now what do we do? Once we have our dots there, now we pick a number, right? So what do you wanna pick?
1.
1's over here. So if I put in 1, I'm gonna have 11 over negative 2. If I put in 1, I get negative 3 plus 14, that's 11. Divided by 1 minus 3 is negative 2. Is 11 divided by negative 2 less than 0? Yep. So I shade that. And then I don't shade that, and I do shade this. So my answer is negative infinity to 3, or bracket 14/3 to infinity. That's a tough problem. There's a lot to keep track of in that problem. This hasn't really happened to us before. If you can't, like, I can look at this denominator and tell you the dot's gonna be at 3. That's pretty obvious. But if you have a thing and you can't really tell where the dot goes, then just set it equal to 0 and solve it, and that will tell you where the dot goes. Denominator dots are always open. Once you get the dots on there, pick a number like we've been doing and see if it works, then you can alter it. Okay, we ready to try another one like that? Okay, number 11. Okay, I just erased it, but you have it written on your paper. What is the first thing I want to do? This is an inequality. So I'm not gonna be multiplying this over. What am I going to do instead? I'm gonna get it set equal to 0, or greater than 0. I'm gonna get this number to be a 0. So 3x plus 1 minus 2 greater than 0. So look at that, make sure you got that. Everybody okay with that? All right, what's the next step? You can tell me what the next move is going to be. I gotta get the denominators to match. So, the denominators will match if I just give this one an x minus 1. And it's always gonna work that way because you're always just gonna be subtracting a number over. So you're just gonna have to multiply the top and the bottom by that denominator. So my common denominator is x minus 1. You can't lose the denominator in an inequality. In an equation, I know it's confusing, I can't help it. In an equation, you can drop the denominators. In an inequality, you have to keep it. It becomes a dot. All right, so what's on top? 3x plus 1. Be careful here. What's this going to be up here on the top? Minus 2x plus 2. Remember, it's negative 2 times x and negative 2 times negative 1. Okay, you're writing this down? Follow along here. All right, so what's on top this time? X plus 3? Oh, that's easier. This one's not bad. Can you tell where the dots are right now? Yep, the dots are at 1 and negative 3. Now in this problem, aren't they both open? So what do I do now? Pick a number. What number do you want to pick? Two's out here. So if I put in 2, I get 5 over 1. If I put 2 into my problem, is 2 over 1 bigger than 0? Yep. Shade that in, don't shade that, and shade that. And then I'll write my answer in an interval. So negative infinity, negative 3. Or 1 infinity. Now, we're gonna practice some more of those. Every practice test has one of those on it, because it's a test question. But right now, we're gonna just recap a few word problems, because they're on your test too. So I'm just recap a couple of them, and then we'll start reviewing. All right, anybody have a question about this problem, any step of this problem? This one was easier because the numerator was so simple. It wasn't like that last one. But the strategy is the same. Okay? All right, let's look at the word problem here. Oh my gosh, a mixture problem. This is a blast from our past. Guess what? We're doing them again. How do we set this up? Who remembers? Amount times percent plus amount times percent equals amount times percent. Remember that? Those percentages are always going to be given to you, so we should be able to plug in the percentages. How much 12% needs to be added to 5 gallons of 15% to get a 14%? Does my putting the percentages where I put them, does that make sense to everybody? Okay? All right, now I need the amounts. How much, how about we call that X? How much needs to be added to 5 gallons of 15%? Oh, that's mine. I've been getting a lot of answers from this, so I'm not answering it. Shut up. Okay. What goes in this last one over here?
X plus 5.
X plus 5, or I like to put 5 plus X, it doesn't make a bit of difference. X plus 5, 5 plus X, whatever flips your switch. Okay, Gio? How do you get what?
Percentages?
Are you reading the problem at the bottom of page 23?
Oh,
All right, so here we go. Might need a calculator for this, so feel free. That's 0.75, I'll double check it on my calculator. This is 0.70. All right, I'm gonna double check these on my calculator. It's Monday morning. And I wanna make sure I'm not making mistakes. Okay. All right, then we'll just solve our equation. So if I subtract this over, sometimes we are careless on this. 0.14 minus 0.12 is gonna be 0.02. And then we'll subtract this over, and that's gonna be 0.05. So you've got a calculator, so there's really no excuse for, arithmetic mistakes. You can type it in on your calculator, and I got 2.5 gallons as my answer. will number 2 have the same kind of setup? Why, yes it will, Mrs. Ford, because isn't it another mixture problem? Yep. So let's put, this is number 2. Now we're doing coffee, or no, acid solution. So how much, or no, not how much, 8 cups of 54% is mixed with some 84%. And I get a 60%. So take a look at that, make sure those percentages look okay to you. Now this one's a little different because normally the problem starts saying how much, but this doesn't. This says 8 cups of 54%. So does that make sense to you? That there's an 8 there? Need to be mixed with some 84%. We get a 60%. How much 84% is needed? Does that make sense that the X would go there? And then how much am I gonna end up with? If I mix 8 cups and X cups, then what's this gonna be?
8 plus X.
8 plus X. So look at that. This is gonna be a test question again. Look at it and make sure you understand why we put the numbers where we put them. This time I got 2 cups, but I'm gonna let you check that a little bit. Make sure that's what you got. I subtract the 4.32. And subtract the 0.67. I think that's right. That far yet? Did they get that yet? Any question about it? The setup or the solution? Okay, we have one more kind of problem to do, and I can't remember, but I don't think we've done these yet. Have we done, well, just read number 3 there. Danielle can do the homework in 4 hours and so on. Does that look at all familiar? I don't think we've done any of these yet. I think this is our first one. Okay, so clearly that is not a mixture problem, right? Problem number 3 is not a mixture problem. I'm not mixing anything. This is a work problem. You have 2 people doing a job, and they can either do it individually or they can do it together. Well, we have, like, this is our setup for mixtures. We have a setup for this kind of problem too. 1 over the first guy's time alone plus 1 over the second guy's time alone will be 1 over their time together. So if you have 2 people doing a job, you can always figure out the answer by setting up 1 over Susie's time alone plus 1 over Billy's time alone. That will give you 1 over their time if they do the job together. So for problem number 3, Danion's time alone is 4 hours, so 1 over 4. if Zach helps her, it will take them 3 hours. Where does the 3 go? 3 is their time together. What am I looking for? Zach's time alone, right? So there's my equation. You okay with that? So now, I have an equation that is exactly like the quiz you just took. It's exactly like the quiz. What's our common denominator gonna be? 12x. 4 times 3 times x. So this one needs a 3x. This one needs a 12. And this one needs a 4x. Every denominator has to have a 3, a 4, and an x. Times, multiply. 3 times 4 times x. So this one had a 4, so I gave it a 3 and an x. This one had an x, so I gave it a 3 and a 4 times 12. And this one had a 3. All right, so 3x plus 12 equals 4x. Because once the denominators are the same in an equals problem, I can drop them. So 3x plus 12 equals 4x. So it looks like x equals 12 hours. It takes Zach 12 hours to do it by himself. That's the first one of those we've done. So look at it and then ask me what you're not sure about. How a number got in there or why it's where it is. All right, do you feel like maybe you can set up number 4? It's the same thing. You have Brent and Matt doing something. So 1 over alone plus 1 over alone equals 1 over together. So what's the setup for problem 4 going to be? 1 over 8 plus 1 over 6 is 1 over x. Now don't stress about a common denominator. There are lots of common denominators you could use. Would you agree we need an 8, a 6, and an x in every fraction? That's the easiest thing to do. It isn't the smallest thing to do, but it's the easiest. If we need an 8, a 6, and an x, then this one's going to need a 6x. This one's going to need an 8x. And this one's going to need a 48, a 6, and an 8. These are times. So we have 6x and 8x adding up to 48. I got 24 over 7 hours. But I'm gonna stop and wait for you to ask a question if you have one. Let's look down at the bottom of that page, and there's a couple more word problems down there. I know there's not much room there. Maybe you can squeeze it in, and you'll need your own paper. But let's look at number 3. Can you set up and solve number 3 on your own? Amelia and Erin are painting the room. See if you can set that up. Okay, who can tell me what you got set up? Elijah, what did you set up here for this Amelia and Aaron problem?
1/4 plus 1/8.
Beautiful, beautiful, beautiful. That's the setup. Anybody have a question about it? Good. So now, Erickson, what do we need our denominators to be? We need them all to match. So what do we need them all to be? 4x. So we're gonna multiply this one by an x, this one by a 4, and this one by a 4 and an x. So x plus 4 equals 4x. Anybody get 4/3 hours as your answer? 1 1/3 or 4/3 hours? I know these are the first of these you've done, but usually they're pretty easy. Are you kind of getting a grasp of that? All right, let's do that bottom mixture problem, and then we'll start reviewing for our test. All right, so this is gonna be an amount times a percent. All right, so here we go. What are our percentages in this problem? 16. 2, now remember, 2% is 0.02, 0.02, and 10%. Right, what are the amounts then? What goes here? How much? X needs to be mixed with 9 quarts. What's gonna go here? 9 plus X or X plus 9, that's exactly right, that's the total. Add them together, that's the total. We good with the setup? All right, then go ahead and solve it on your own. I'll solve it too, but you solve it first instead of just watching me write stuff down. .16x plus, what'd you put here? What'd you put there? 0.18, yep, 0.18, 0.18. And what'd you put over here on this side? 0.10x plus 0.9. Could you have a calculator? There, no excuses for getting wrong numbers. Type it in on the calculator to get your answer. All right, so we're going to subtract this from both sides. So I have 0.06. Watch that. Use your calculator. Subtract this from both sides. 0.06x equals 0.72. So I got 12 quarts. Anybody else get that worked it out? Get 12 quarts as your answer. Now, the last page here of things is extra word problems. The answers are on the back. Feel free to work on those if you need more practice with mixture problems. find the mixture problems on here and do them and compare with what's on the back. You do not need to worry about number 7. Number 7 is a mixture problem, a type of mixture problem, but instead of doing percentages, it has money, so I don't wanna confuse the issue, so feel free not to worry about number 7. But the rest of those are there for you to practice if you wish. Okay? All right, let's get out our practice tests and let's start getting ready for a test. Okay, well, the first page is the big problem. This is our big equation. We have to graph it, and we have to find all that stuff, like we did on our quiz. Start. Factor. So how does, this is an easy factoring, you can do this. How does the top factor? So the x and x. And then I think 3 and 2. Do you think 3 and 2? Because when I add them, I have to get -1. So it's gonna be -3 plus 2. And I think that's right, but I'm gonna FOIL it just to make sure. X squared minus 3x plus 2x minus 6. Yep, that works. That's right. So I'm good on that. How does the bottom factor?
X plus 2, X minus 2.
Difference of squares, x plus 2, x minus 2. That's exactly right.
I don't have that practice test.
Well, it might be back there, and you might have to get one online. There's probably some back there. All right, so what do we do? What do we notice? Well, we can cancel, which means we are definitely going to have a hole in our problem. And what do we know about the location of that hole? Where's it gonna be? Where x is -2. Look at it. Look where I put the hole. Right? Now how do I get the other part? Because I'm gonna plot that point on my graph. How do I get that right there? Plug that into here. Do not try to go back and plug it in the original. It won't work, you guys. You gotta plug it in right here. So -2 minus 3 is -5. And -2 minus 2 is -4. So those negatives cancel, that makes 5/4. So on my graph, I'm gonna find where x is -2 and y is 1 1/4. And there it is. And we'll label it. All right, now what? What else? You got the whole list of what needs to go in your picture. What else do we need to put in there? We have our hole covered. Is it 1? Very good, Brennan. Very, very good. Horizontal asymptote is 1. Y equals 1. And he got that by boxing in the x's. Horizontal asymptotes come from boxing in. Perfect. What else do I have?
Vertical is 3.
The vertical, no, the vertical asymptote is x equals 2, because where do vertical asymptotes come from? Denominator. So my vertical asymptote comes from right here. It's a cannot be. X can't be 2. And whatever x can't be is your vertical asymptote. Okay. What else do I have? I gotta get my intercepts. That's the only thing left. I have to find my x-intercept and my y-intercept. So I have an x-intercept at 3, because where do x-intercepts come from? They come from the numerator. What makes the numerator 0? So that would be 3. Your vertical asymptote comes from the denominator. Your x-intercept comes from the numerator. And then how do I get my y-intercept? Plug in 0. And when you plug in 0, this is kind of an easy one. Don't you get negative 3 over negative 2? Which is 3/2. So if you're looking at your list of stuff, this is your x-intercept, because look where it is. It's on the x-axis, so that's your x-intercept, and this is your y-intercept. This is your vertical asymptote. Look, it's vertical. This is your horizontal asymptote. Based on that, can you draw the picture then? Yep, it's a reciprocal function. So just like on your quiz, kids, I'm not going to give you a tricky fancy one. You are going to be sketching a normal picture, just like this. You okay? Everybody good? Alright. Remember, your test looks just like this, right? So you're gonna have a problem, that's gonna be a whole page of your test, just like it is here. Alright, we ready to go on? Okay, now we've got some inequalities. Or at least one, yeah, no, a whole page of inequalities here. So x squared greater than or equal to 6x. So I know I'm going to be using a number line. Because anytime I have that, I have a number line. Now, also, anytime I have that, what do I like to have on one side of my equation?
0.
A 0. So the first thing you're gonna do, I hope, is move that over. So x squared minus 6x greater than or equal to 0. So does anything occur to you at this point? Does it look like maybe we want to do something here? You could complete the square, but that's gonna be problematic because it's an inequality and I can't square root an inequality. I can have this factor. Doesn't this factor?
X minus 3 minus 2.
Take out x.
Exactly. All you can do is take out a GCF. Good. Now, I heard some other factoring ideas. Remember, whatever factoring you do, Gabby, you can check it. Okay? So it's okay to have a thought, have an idea, but then check it and make sure it's right. If I check Brennan's, it's right, x squared minus 6x. Where does that tell me to put the dots?
6.
At 0 and 6, right? Will those dots be open or closed? Closed. Remember, it's only dots that come from a denominator that I have to worry about. There's no denominator in this problem, so we're equal to closing it. Now what? Pick a number. I might do 1. All right, if you do 1, it's in here. 1 is in here. So that would be 1 times negative 5. Put in a 1 here and a 1 here. You get 1 times negative 5. Is that answer, 1 times negative 5, bigger than 0? Nope. So don't shade there, shade here and here instead. So negative infinity to 0, use a bracket on that 0, and a bracket on your 6. That's the answer to the question. Okay? Now, we'll do one more. This is the one we did for the first thing this morning. So let's see if you can remember. You've only done a couple of them, but we just did them, so maybe it's fresh in your memory. What do we do first? Subtract the 6. And keep in mind that that 6 is like 6 over 1. It's a fraction. Then what? Give this guy an x plus 3 so that he matches the first one. Keep the denominator, because it's going to be a dot in the picture. The numerator is x minus 2 minus 6x minus 18 minus 6x minus 18. Negative 5x minus 20. Collecting like terms, everybody okay with that? Now, I know I'm gonna have a number line, and I know I'm gonna have a couple of dots. I know one of them's gonna be at negative 3. This always messes me up. So I'm gonna say negative 5x minus 20 equals 0. I'm gonna add 20 and divide. So it looks like my other dot is gonna be at negative 4. From the numerator, it's at negative 4. So I have a dot at negative 4 and a dot at negative 3. This is one of the tricky ones. It looks like I would color in the dots, and I do, except for the denominator one. So this one gets colored, that one does not. Okay, now quickly I'm gonna pick a number. I'm gonna pick 0. 0 gives me a negative number, so 0 works. So this is colored in, and this is colored in, and I have my answer. Sorry, I'm rushing to get this done. So that's my answer. I put in 0, and negative 20/3 is less than 0, so 0 worked. So then I did every other line and got that answer. Okay, we'll pick up there tomorrow. Or sometime when I see you again, we'll pick up there. Have a good day. We are reviewing, so feel free to come in and practice.